All right. What I want to do here today is show you how to go ahead and use some of the information we learned about the Hardy-Weinberg equation in the last video. I want to give you some examples of some practice Hardy-Weinberg problems because I'm going to be assigning some for you to do. Um, should we be able to get back to school here sometime soon, you will have a test that will include Hardy-Weinberg problems on it. And the AP test always works a Hardy-Weinberg problem in somewhere. So I wanted to walk you through one example that's a little on the easier side and then one that's a little bit more on the challenging side here. So let's take a look at this first question here that says, if 36% of the individuals in the population have the recessive trait, what is the frequency of the recessive allele? Then it asks for the frequency of the dominant allele, the homozygous dominant genotype is what that should say, and then what is the frequency of the heterozygous genotype. So let's start with the first piece that we need to figure out, and that is this. We're given that 36% of the individuals in the population have the recessive trait. So which of our Hardy-Weinberg terms have we been given is the first thing that we need to figure out. Because if you remember what we have a variable that was p, and we had one that was q, and then we had p squared, we had 2pq, and we had q squared. So which of our 5 Hardy-Weinberg values do we have? Remember, p plus q is supposed to be equal to 1, and then p squared plus 2pq plus q squared is also supposed to be equal to 1. So we have 36% of the individuals in the population have the recessive trait. In order to have the recessive trait, you must be homozygous recessive. Which of our terms represents the frequency of homozygous recessive individuals? Well, that is q squared. So q squared is equal to 0.36. So now that I have one of my values here, I should be able to start figuring out some of the other terms in this equation. For example, if I know q squared, what else can I figure out? I'll give you a second here. Hopefully you came up with, if I know q squared, I can figure out the value of q by simply taking the square root of q squared, right? So if I take the square root of q squared, and let's see if this catches up or not. What that means is I'm going to be taking, and I'm working right here, this is the square root of q squared, there we go. What that means is I'm going to be taking the square root of 0.36. And I know this isn't calculus, so some of you guys may actually struggle with this a little bit, but that is going to be equal to 0.6. Okay, now if I have q, what other value can I figure out? Right, I can figure out p, because I know that p plus q is equal to 1. So since I have p, I have a value for q as 0.6, p plus 0.6 is going to be equal to 1, and therefore I know that p is equal to 0.4, right? Because 1 minus 0.6 is 0.4. Now that I know my value for p, what can I figure out? I can figure out p squared by taking 0.4 and squaring it. And that is going to be equal to 0.16. And once I have p squared and q squared, I can figure out 2pq by subtracting for 1, or I can just do 2 times p times q. So 2 times 0.4 times 0.6. And that is going to be equal to 0.48. So that's the frequency of heterozygous individuals in my hypothetical Hardy-Weinberg population here. And one thing I want to make sure I do a quick check of once I finish, do p and q add up to 1? 0.4 plus 0.6? Yes, they do. And then do p squared plus 2pq plus q squared add up to 1? 0.16 plus 0.48 is 0.64. 0.64 plus 0.36 is 1. And I've done that first problem successfully. So, second problem, a little more challenging here. All right, so let's take a look at it. It says here, in a recent study of 5,400 people, 4,914 of them did not have the recessive trait of having a cleft chin. Move my mug out of the way. What is the frequency of the recessive genotype in the population? What is the frequency of the recessive allele? How many recessive alleles are there? What is the frequency of the dominant allele? What is the frequency of the homozygous dominant individuals? What is the frequency of heterozygous individuals? How many heterozygous individuals are there? That sounds like a lot of work. So let's break it down and do just one question at a time. The first question, what is the frequency of the recessive genotype in the population? So I know that I have 5,400 individuals here. So when I take a look at that, I know that 5,400 individuals are in the population. 4,914 of them do not have the recessive trait. So that means that 486 of them do. So I know that there are 486 recessive phenotype individuals in the population. If they have the recessive phenotype, then that means that they must be homozygous recessive. So to figure out the frequency of the recessive genotype in the population here, I'm going to simply take my number of homozygous recessive individuals divided by the total number of individuals, and what that works out to be is 0.09. Now, which value in my two Hardy Weinberg equations represents the homozygous recessive frequency in a population? And hopefully you know that that is going to be my Q squared value. Okay, so I just answered the first question. What is the frequency of the recessive genotype in the population? Now the second question, what is the frequency of the recessive allele? Well, which term is equal to the frequency of the recessive allele? Well, that's Q, right? So how do I figure out Q? I'm just going to take my value for Q squared, which is 0.09. And to figure out Q, I'm going to take the square root of Q squared, which is the square root of 0.09, which is 0.3. So the frequency of the recessive allele is 0.3 or 30%. Now this next question is kind of tricky. It says how many recessive alleles are in the population? So for this one, I've got to first figure out, well, how many total alleles are there in the population? Well, if I have 5,400 people and each one of them has 2 alleles for this particular trait, then for this trait, there are going to be 10,800 total alleles in the population. And from that, I know that 30% are recessive. 30% of the alleles in this population are recessive. So I simply need to figure out what is the homozygous recessive number of alleles. And the way to do that is to take my total number of alleles and multiply it by the recessive allele frequency of 0.3 or 30%. So when I do 10,800 times 0.3, I get a value of 3,240, and that is how many recessive alleles there are in the population. The rest of the alleles are dominant alleles. Okay, let me just add this here, recessive alleles. And 10,000, let me put the total alleles. Okay, so next question. What is the frequency of the dominant allele? So the dominant allele is represented by P in our equation. We know that P plus Q equals 1. We know that Q is equal to 0.3. So P must be equal to 0.7. Okay, so that's the frequency of the dominant allele in our population. The next question, what is the frequency of homozygous dominant individuals? Well, which term represents the frequency of homozygous dominant individuals? P squared. So P squared equals 0.7 squared, which equals 0.49. And then the next question that we can take a look at was, what is the frequency of heterozygous individuals, okay? And when I take a look at that, what I'm going to find is the frequency of heterozygous individuals. Pull this down here and trying to get caught up here. It seems to be lagging a little bit in the sharing between my laptop and my iPad. So let me just make sure that it doesn't crash on us here. Well, how you guys doing? I'm going a little stir crazy, not gonna lie. I'm starting to make way more videos than I need to all at one time. Let's see if this can catch up or not. Ah, there we go. Okay, so let me reconnect. Got the spinning circle of death right now on my iPad, just waiting to connect. Hopefully it happens soon so we can get back to this. There we go. There we go. Come on, get caught up. Show it. Let's go. Okay, so here we go. So question we were on was, what is the frequency of heterozygous individuals? So what I got to do here is 2 times P times Q, which is 2 times 0.7 times 0.3, which is equal to 0.42. So 42% of the individuals in this hypothetical population were heterozygous. So then the next question is, how many heterozygous individuals are there in the population? Well, again, I'm just going to have to simply take my total number of individuals, because I'm talking about individuals here. I'm not asking about alleles. I'm asking about individuals. And I know I have 5,400 individuals in this population. And I know that 42% of them are heterozygous. And when I do 5,400 times 0.42, I get a value of 2,268 heterozygous individuals. So there you have it. That's how many heterozygous individuals there are in the population. So that was one example on the easier side to start, and then a little more challenging one here at the end. One of the real keys that you're going to have to remember is how to tell the difference between, all right, are we being asked about heterozygous individuals, homozygous recessive individuals, homozygous dominant individuals, or am I being asked about alleles? Am I being asked about what is the allele frequency versus what is the frequency of a genotype? Because if you're asked about an allele frequency, it's either going to be P or Q. If it's a genotype frequency, it's going to be P squared or 2PQ or Q squared. That is where students always get tripped up on these problems. So hopefully these two examples were enough to get you going on some of the homework that you're going to get. If you have any questions, please, please, please feel free to email me and I will do my best to help you out. Have a great day. Be safe. Stay healthy.